Hey guys, hope everyone's doing well. For those of you who don't know me, my name is Logan, and I started working on a project a few weeks ago just to share out something that I got really passionate about over the last few months, which is, I guess, cryptocurrency, blockchain, NFTs, and some of this new technology that's coming out that you guys are probably hearing about. And I was getting a lot of questions, some technical, I suppose, really interesting questions, and some just like general confusion and misunderstanding about these topics. So I wanted to put together a few videos, just introduction videos, kind of explaining how I understand this technology. Not that I know everything, right, and not that I'm incapable of mistake or error, right, but I do have a little bit of background here, and I just wanted to share, like I said, something that I'm passionate about with all you. Just, I guess, a little bit about me if you don't know who I am. I did attend the University of Colorado, graduated with a degree in 2018. Let's go Buffs. And for the last 5.5 or 6 years or so, I worked in tech, in the tech industry, I suppose. And in particular, for the last 4 years, I worked in teaching tech. So, I may not have a perfect understanding, but I do feel like I have a pretty good way and methodology of explaining some of these really dense subjects in a way that normal people can understand, or not tech folk, I suppose. Anyway, so I do have plans. This video is on blockchain, just about how blockchain works and what you can do with it, and why it's I think an incredible technology. But I do have plans for 2 more videos. One just about cryptocurrency in general, all the different coins that you can do all kinds of different stuff with, how that works and how that fits in with blockchain. And then one on NFTs, non-fungible tokens, and how they work, what they are, I suppose, is a big question that I'm getting a lot of, and how they relate to crypto and blockchain. So we're starting with blockchain just because it's kind of the basis for everything else. But yeah, so that's this first video. Please, I hope you enjoy the video. If you do, like it, share it, follow me on social media. I'll be putting out more videos, and if you have questions or anything, feel free to reach out. I'll answer as many of them as I can, as best I can, because it's just something I'm passionate about. Like I said, I'm just here because I love it. So yeah, I hope you enjoy it. Okay, wanted to take a second here just to explain a little bit about blockchain, how I understand it, and just what it is in general. Just because it's kind of a new technology, but I think the implications of it are pretty far-reaching. It's going to have an impact, I think. So let's go ahead and get started. When it comes to a lot of these like really dense technical subjects, right, I think it really helps to visualize them in something that's real, something that's tangible, because they're not they're not tangible. They're digital. So in terms of blockchain, I think Legos are honestly the best way to do it. So one block in the blockchain, right, would be equivalent to just our one 2x2 Lego here that we have. And all the blockchain is all these Legos attached to each other and stacked up. Gives us a blockchain. And so I guess the question then becomes, right, what is one block in the blockchain made out of? And the short answer is essentially code. The long answer is a little bit more technical than that, because you have a lot of different kinds of code. Code that does different things, that means different things, and that functions in different ways. So most blockchains are written or use what's called hex-digit code, which is just a 16-digit code. It's the numbers 0 through 9 and the letters A through F. It's not your typical computer code, right? It's not what you would see some software engineer programming in or anything like that. It's an encrypted code. It's encryption is really what it is, which is, if you want to get like really basic about it, it's just hidden messages. In terms of blockchain, it's hidden messages that don't mean anything. So I guess essentially there are 2 parts of any given block on a blockchain. There's a block header, which you can imagine as like the 4 dots on the top that allow your Lego to be built into the rest of the block, or the rest of the blockchain. and then you have the body of the block, which is just, I suppose, everything else besides what's on top. And so from here on out, we'll get into the block header a little bit, and I'm going to use this flat black piece to represent the block header, and this gray piece will represent the body of our block. So we'll attach the body of our block to our block header, and we'll get going. So in our block header, we have a few different things going on, a few different types of code in here that do some different things. And the biggest one, the one that we'll start with, is called the nonce, N-O-N-C-E, which stands for number only used once. So it's only used once in every block. So each block has a unique nonce in the blockchain, and each nonce is unique to that block only. The other, I suppose, codes contained within the block header allow it to be attached to the rest of the blockchain. So a little bit of information from the previous block, and a little bit of information and really more rules about the current block. But all that information is all encrypted in this hex digit code, and it's all contained in our black piece here, in the block header. And the other piece of a block is the body of the block. So the body of the block contains really just one thing. It contains a lot of stuff, but it's all pretty much the same thing. And it's all just transactional data. So think about it like one of those really big, long Walmart receipts, I guess, that you get that just lists out item after item after item after item. That's essentially what the transactional data is. In terms of crypto, it's just like a ledger. It just functions like a ledger, keeping track of everything that's going on within your blockchain. So once again, it's all encrypted, but it would say something like, you know, Bob sent Tim 3 Bitcoins. Or, you know, Tim sent Sally 1.5 Bitcoins. You know, anything like that. Anything all encrypted, just contained in the transactional data. And it continues running, just like your Walmart receipt would, until the block is mined, until the nonce up here, which is the number only used once, which is a question mark. No one knows what this is at first. It's hidden until it's discovered. Once it's discovered, transactional data stops flowing into the body of the block, and the block is considered mined. So we're going to get a little bit here into mining, just so you can understand better how blocks are created, or I suppose so I can explain better, hopefully, because it's on me to help you understand, I suppose. So when it comes to mining, there are two basic things we're looking for, right? So the first is that the nonce is discovered. So our number that's only used once is discovered by someone, or by a miner, really is what I should say. So the nonce is discovered, and what's called a proof of work is completed and is valid. So I'll get into a little bit of what this proof of work is. This is probably the most technical piece of blockchain and most technical thing I'm going to get into in this video. So I think to explain mining, it helps to think about a situation where we have a job fair, right? So we'll set up our job fair over here. I think about these when I was on campus, right, in school. You would show up to the job fair, and you would check in at the front desk or whatever, and they give you a name tag. And it would say, hello, my name is whatever, and so you would write your name on that. So we'll have me in the job fair, obviously, because I need a job. So we got me, maybe we got Jim, we got Sally, we got Jenny, and we got Tommy. And we're all in the job fair currently. And so for the purposes, essentially this nonce is our name. This nonce is what goes on our name tag. So, and that's actually a good way to think about it. The nonce is the name tag for any given block. So these are our blocks here, and those are our name tags, our nonces. And so what happens is, say, we've got a guy, Jeff, who wants to come into the job fair. So we've discovered a new nonce down here, we think. Jeff's our new nonce. The proof of work is the check to make sure, since each nonce can only be used once, so only used once, is the check to make sure that there's not another Jeff in here in our job fair, right? If there is another Jeff already in the job fair, obviously Jeff can't come in because we can only have one of everyone. I know that's a little strange for a job fair, but I think it helps to think about it like that. The nonce is only used once. Once it's discovered, or we discover a potential nonce done by the miners, it's submitted to the blockchain, anyone connected to the blockchain, for a proof of work. So each mining machine will run down the entire blockchain, every block that's already been mined, and say, this is our proposed nonce. Does it match up with any of these that have already been verified? If it does, it's no good. If they get through the entire blockchain and they find that this nonce, Jeff, for example, isn't in the job fair yet, he can come on in. And in which case, you have a new block that has been mined once the proof of work gets completed. This proof of work, I suppose I should go into a little bit more, doesn't just apply to mining a new block. It applies to any transactional data that's coming into the blockchain. So in terms of crypto, right, anytime you make a purchase, anytime you buy Bitcoin, anytime you sell Bitcoin, anytime you do anything through the blockchain, it's going to record that transaction. So you sell Bitcoin, you buy it, you loan it, you trade it, send it to someone, do whatever, a transaction gets created in the blockchain. Anytime the transaction gets created, the blockchain has to get validated, which is essentially the process of proof of work. Rather than looking to make sure that the nonce is unique, essentially, though, what they're looking to is just ensure the validity of the blockchain. So anytime you create a transaction on the blockchain, it comes with a time and date stamp. It comes with the amount, right, or what's happening, what's being sent to who, and it's all encrypted. So essentially, it's just a string of code, but it's got one address sent whatever or did whatever through the blockchain to this other address at this time and date. So what it's looking for is just any transaction that appears to match that exactly. Think about it like in terms of even regular money, right? If you were to like try to spend money out of your bank account at the exact same time in two different places, it's not possible. It doesn't work. Which I think makes sense, right? Even if you were to try to make back-to-back transactions as quickly as you could, there's going to be 1 second in between there, right? So when you validate the blockchain, all it's looking for is that this transaction exactly doesn't appear anywhere else in the blockchain. Okay, so what does this all mean, I suppose? A lot of different things. But let's go ahead and start with the first point. So the nonce, and I suppose I forgot to explain this the first time, but the nonce is 16 digits long. And that has to do with the way that the code works, right? Hex digit code, 16 digits. Your nonce is going to be 16 digits long. Anyone with a little bit of logic can see that 16 digits, there are only a certain number of combinations you can have of 16 digits. And since each nonce is a number only used once, there are a finite number of combinations you can have for each nonce. So that being said, there's a finite number of blocks that can be created on any given blockchain, meaning that your blockchain it's gonna end at some point. There's gonna be a limit to it. To put it in perspective, I guess the Bitcoin blockchain is going to be capped at about 21 million blocks. That being said, at the rate we're currently mining Bitcoin, we're not expected to reach that until about the year 2140. So we got a ways to go, but there is a limit to it. And so anyone who has studied economics understands that any limited resource is going to appreciate with demand. So as demand for any blockchain good rises, because it's finite, it's going to appreciate. I suppose the second thing that this blockchain technology means is security. Because of the way the blockchain works with proof of work, and because of the way transactional data gets validated, the blockchain gets validated very frequently. So every transaction that is made, the entire blockchain gets validated. Anytime you would make a transaction on blockchain, it's going to get validated. And after you've made your transaction, it continues to get validated. So for Bitcoin, it typically takes about 10 minutes to validate that blockchain. But one of the things I suppose that means is that if any bad actor were to come in and start trying to mess around in the blockchain or do anything that's just not morally sound, morally correct, everyone that's mining or everyone connected to that blockchain network, is going to know within about 10 minutes, is going to know exactly what happened. So it provides a level of security through transparency. It allows the users, I suppose the miners in this case, but any user that can connect to the blockchain, allows them transparency to see what's going on. So I get this question and this point a lot that's like, oh, someone's going to come and steal all your Bitcoin. Like, not really. They would get caught in about 10 minutes guaranteed. And you would need a lot of information to steal someone's Bitcoin. So it's not really feasible. That being said, there are bad actors in just about any industry, so you do have to be careful with it. But blockchain kind of offers you at least the transparency to see what's going on. And the last, I think, big point that blockchain offers is that pretty much any blockchain is run through the internet. There's an R there. And I think the biggest point when it comes to being run through the internet is just, I get a lot of people that bring up the point or ask the question or make the argument that the government's just going to come in and regulate this, right? That some government agency, the FEC, the SEC, the Fed, I guess, whatever it may be, is just going to come in and regulate blockchain or crypto or any of these digital markets. To my response, I would say good luck. Because it's run through the internet, you would have to regulate the entire internet. So by that I mean essentially anyone that can connect to another miner or another machine on the blockchain is going to be able to mine that blockchain and is going to be able to complete the proof of work, do whatever it needs to do in order to continue to run the system. So you'd have to regulate really the entire internet. You would have to censor it somehow. And I suppose on that note, the other big point, or I guess this is just a point that one person had made to me, was what if a nuclear weapon gets detonated and the EMP knocks out the internet or something, which I suppose theoretically could be possible. If you detonate a nuclear device in space, it creates a big enough EMP to knock out most of the electronics in the world. That being said, in that situation, we're going to have a lot bigger problems than what happened to our cryptocurrency. We're going to have problems like we don't have power. We don't have the ability to sanitize water anymore. So we're going to have essentially a post-apocalyptic situation on our hands, in which case no currency is going to be good. It would, in my mind, devolve into a commodity market. But I suppose that's essentially the very basics of blockchain and the implications that it has. Like I said, it's going to be finite, so any finite resource appreciates with demand. It's got a higher level of security. I wouldn't say higher, different level of security. It allows a more personal security. It allows the user to really take control of that interaction, that transaction, and have transparency into it. And because it's run through the internet, it's really tough to regulate. We're seeing, I guess, most recently we saw Turkey banned people in Turkey from buying Bitcoin or buying any crypto, which again it's tough to do. they're currently kind of doing it, but they're just not allowing people access to that portion of the internet, which again is censorship. Um, Something that I don't think would ever happen in a westernized country. If it did, you'd have some pretty some pretty big issues on your hands. And because it's run through the internet, in order to shut down any blockchain or Bitcoin operation, any cryptocurrency, anything like that, you would have to shut down pretty much the entire internet. As long as someone can maintain a connection to the blockchain, it's going to be there, and they're going to be able to mine it. They're going to be able to use it for transactions and everything like that. So, hope you liked the video. Feel free, give me a like or retweet, whatever. Follow me on Twitter. I'll be posting this on YouTube at some point, I'd imagine. But yeah. So I know just a few seconds ago, I mentioned something about Turkey having banned people from Bitcoin or something, and I just wanted to issue a bit of a correction, I suppose, on that. It wasn't entirely incorrect, but it wasn't the full truth. I suppose so. Turkey is currently banning Bitcoin as an acceptable form of currency. So, you know, if you have Bitcoin in Turkey or whatever, you're just not really allowed to spend it anywhere, which I don't believe would fly in any westernized nation, like I said. Um, we'll see how it goes for Turkey. I don't think they're going to be very successful. As I mentioned previously, right, in order to ban any sort of blockchain anything, any blockchain good, you would have to ban the internet essentially, or censor the internet somehow, which, aside from being really difficult and virtually impossible, is definitely not something that would really ever happen in a developed democracy. So there's that.